Good afternoon, my dear students. Now let us do one simple problem. So here the problem is let us once again let us read the problem. That is, a discrete system is given by the following difference equation: y of n minus 5 into y of n minus 1 is equal 4 into x of n minus 1 plus x of n, where x of n is the input and y of n is the output. Determine its magnitude and phase response as a function of frequency. So it is a given problem. Uh, so in this problem we are going to find out what we are going to find out. We are going to find out the magnitude and phase response. So how we will get this magnitude and phase response? The given one is a discrete time system or the discrete system. Whose difference equation? A discrete system difference equation is given. Okay, in order to calculate the magnitude and phase response for a given difference equation, we are going to apply Fourier transform on both the sides. So that is this side and this side. Okay, so let us do the solution. Let us write down the given difference equation once again. Y of n minus 5 y of n minus 1 is equal, first x of n, right? Just come on. Okay, x of n plus 4 into x of n minus 1. So to determine the magnitude and phase response, we are going to apply the Fourier transform on both the sides. Okay, by applying Fourier transform on both the sides, we get so for y of n, Fourier transform equivalent is, for y of n, a discrete Fourier transform DFT is capital Y of e power j omega. In case of y of n minus 1, by applying discrete Fourier transform to the y of n minus 1, we will get e power minus j omega. Why? Because here we have the minus 1. Okay, e power minus j omega into y of e power j omega. So in case of x of n, for an x of n whose discrete Fourier transform is capital X of e power j omega, for x of n minus 1, the discrete Fourier transform of x of n minus 1, here we have the minus 1 term, that is e power minus j omega into capital X of e power j omega. Okay, so in similar way, let us write down the given difference equation after applying the Fourier transform or the discrete Fourier transform. Okay, by applying the discrete Fourier transform. In the given difference equation, in the bracket we have n, that is, we know that it is a discrete system equation. Okay, so by applying a discrete Fourier transform on both the sides, we will get capital Y of e power j omega minus e power minus j omega into 5 capital Y of e power j omega which is equal capital X of e power j omega plus e power minus j omega into 4 into capital X of e power j omega. Okay, now let us take common, that is LHS, let us take common y of e power j omega. By taking common y of e power j omega, what we will get? 1 minus five into e power minus j omega. RHS side, let us take common x of e power j omega. By taking x of e power j omega common at RHS side, 1 plus 4 into e power minus j omega. Okay, we know that e power minus j omega is Euler's identity. So how we are going to write this, which is write it as cos omega minus j sin omega, like that. Okay, from this let us write down the transfer function. Okay, transfer function and transformation equation. So that is the ratio of y of e power j omega by x of e power j omega, which is equal 1 plus 4 into e power minus j omega divided by 1 minus 5 into e power minus j omega. Output by input, we will get the system function, so which is also called as transfer function, that is h of e power j omega, which is equal to 1 plus 4 into e power minus j omega by 1 minus 5 into e power minus j omega. Okay, now let us use Euler's identity at RHS side. What we will get by applying Euler's identity, as per that 1 plus 4 into cos omega minus j sin omega by 1 minus 5 of cos omega minus j sin omega. Okay, so from that 1 plus 4 cos omega minus 4j sin omega divided by 1 minus 5 cos omega plus 5j sin omega. What it is? It is h of e power j omega. We know that a Fourier transform output is a complex function. Okay, so how we are going to write a complex function? A complex function, for example, consider the impedance. Impedance is equal to the combination of resistance and reactance, that is R plus J X, where this one is imaginary value and this one is real value. So at the time, what is the magnitude? Magnitude of Z is equal to square root of real value square plus imaginary value square. What about phase response? Phase response is represented by angle of Z, which is equal tan inverse of imaginary value by real value. Likewise here also, so this one is a real value in the numerator, this one is imaginary value. Likewise this one is a real value in the denominator and this one is imaginary value. Let us write down one more step. 1 plus 4 cos omega minus j into 4 sin omega divided by 1 minus 5 cos omega minus j 5 sin omega. Okay. Now let us separate the numerator in terms of real value and imaginary value, as well as separate the denominator in terms of real value and imaginary value. Now let us find out the magnitude. In the given problem, we are going to find out the magnitude and phase response. Okay. Therefore, magnitude of h of e power j omega. So according to this, so here real value, square root of real value square by imaginary, and the numerator square root of real value square means 1 plus 4 cos omega whole square plus 4 sin omega whole square root of real value square plus imaginary value square divided by, in the denominator also real value square root of real value square plus imaginary value square, that is 1 minus 5 cos omega whole square plus 5 sin omega whole square. Here minus 4 sin omega whole square means minus x whole square x square. Here also minus 5. Okay. So by simplifying that part, we will get, in the first part it is look like a plus b whole square, that is 1 square, 1 plus b square. So a square means 1 plus b square, 16 cos square omega here minus 4 sin omega whole square means plus 16 sin square omega, and one more term here, a plus b whole square, a square plus b square plus 2ab. What is that term? 2 ones are 2, 2 fours are 8, 8 cos omega divided by square root of 1 plus 25 cos square omega minus 10 cos omega plus 25 sin square omega. Okay, in the numerator part, let us take 16 as common. By taking 16 as common, what we will get? And in the denominator part, we are going to take common 25 from this term and this term. Okay, so by taking common 16 in the numerator part, 1 plus 16 of cos square omega plus sin square omega plus 8 cos omega divided by square root of 1 plus 25 by taking 25 as common, cos square omega plus sin square omega minus 10 cos omega. Okay, so we know that cos square theta plus sin square theta value 1. So cos square omega plus sin square omega value 1. So square root of 1 plus 16 plus 8 cos omega, in the denominator square root of 1 plus 25 minus 10 cos omega. Okay, let us simplify. So square root of 17 plus 8 cos omega divided by square root of 26 minus 10 cos omega. What it is? Which is magnitude of Fourier transform of given difference equation. Likewise, now let us calculate phase response of Fourier transform of given difference equation. So here let us take which part? This one. So after applying Fourier transform, whatever we have, so from that, so here imaginary value by tan inverse of imaginary value by real value. So in the denominator we have the imaginary value as well as the real value. Here, so this one is a real value and this one is imaginary value, and here also it is a real value and this one is imaginary value. Okay, so according to that, a phase response of Fourier transform of given difference equation, that is tan inverse of what is the imaginary value? Minus 4 sin omega. Tan inverse of minus 4 sin omega by 1 plus 4 cos omega. 1 plus 4 cos omega minus tan inverse of. So now we are going to write down denominator. So here the denominator also mentioned in terms of tan inverse of real value, imaginary value by real value. What is that imaginary value in the denominator? That is from this here, this term, from this term. So we are going to write down phase response, or we are going to derive the phase response from this expression. As we have derived the magnitude response from that, same way we are going to derive the phase response from that equation. Okay, that is in this denominator part of that equation is in that denominator we have the imaginary value, that is tan inverse of 5 sin omega. Let us write down that tan inverse of 5 sin omega divided by 1 plus what is that real part? 1 minus 5 cos omega. Minus 5 cos omega. So this one is the phase response of given difference equation. This is a magnitude response and this one is phase response. JDC. First of all, while doing any problem, we should write the given. What is given, what we are going to find out. So given is a difference equation is given, and we are going to find out the magnitude and phase response. So when the difference equation is given and to ask or to find the magnitude and phase response, we should apply Fourier transform on both the sides to that difference equation. After applying Fourier transform, whatever we will get the transfer function, from that we are going to derive the magnitude and phase response. Okay, thank you.